Okay. Exactly. That's what it was. Okay. Okay, perfect. So let's see. I wasn't expecting the stream to start right away, but I haven't used YouTube in a long time, so who knows anymore how things are. So first thing first, I should share the URLs in a few places. Why is nothing working today? It's crazy. Because my keyboard unplugged for some reason. Oh, come on. Are you serious? Connection failed. Like, it never failed to connect and now it does, just because I'm live streaming. This is what I get for doing this. Let's see. So the mouse connected right away, but the keyboard didn't. Unless I guess I'm using the wrong. Okay, that's what it was. Okay. So yeah, so let's share the URL somewhere, and so I'll post it on Blue Sky. Okay. Perfect. So let's see, 0 drop frames. And yeah, so nobody's watching as always, like when I was doing the live streams years ago. Obviously, I didn't put any effort into them, so nobody watched. But yeah. Let's see. Okay. So we should be set. So I shared the link in a few places. I asked if I could share it on the group, and they said yes. So let's see. Will somebody join in this live stream that I decided to do last minute while Amos was too doing something on his channel? So definitely a lot going on today. Okay, let's start anyway, and maybe somebody will join at some point. Basically, this live stream is about something I had in mind for some time, and somebody just an hour ago on the Italian Telegram channel for Rust came up again with this idea, or with the necessity for this. And so I decided, well, why not try to do it live? I used to do some live streams years ago when I did open source, and I stopped because it's a lot of effort to do a live stream, even though I don't put much effort into it. But I was like, let's try again. Maybe this time it will work better. So here's basically what was going on in the group. So basically they had a string, and let's see if I can find it again. So basically it's a normal string, and they want to parse it as a time, but this is not a standard format because there's no time zone here. So the poster originally didn't understand why they couldn't use an RFC 3339 parser, and that this was the reason basically. And so what we told them was they have to declare their own format string for this to work. And this can be done in chrono, in time, in GIF, in whichever crate they usually support time strings, custom time formats. And the way you do it, if I remember it correctly, it would be something along the lines of this, maybe. I never remember this horrible format, but this is what they would do. But here's the problem. They are not... they actually don't have a string. They have a JSON or something else they're trying to parse with Serde. So they have their own. So let's add Serde to this project. Sorry, it's lagging because this is a remote thing. So let's add Serde so that I actually have something for Rust Analyzer to do. So they have a deserializer. And obviously Rust Analyzer never works. So they have something like my date, and they want to parse this as I believe a date time UTC from chrono. So let's also add chrono. Why not? So this then will work, okay. And let's see if it does this now. It doesn't. Because it's deserialized, not deserializer. Here we go. And let's also add Serde JSON at this point, why not? And we'll write a test. Where we are going to try to deserialize this. So we'll do Serde JSON from stir. So their input is something along the lines of my date. And they have this without the Z at the end. And if we run this, obviously it will fail. Not because of this reason, actually. I didn't enable the SRD feature on Chrono. But it panics because it says there's a premature end of input because there's no time zone. And you can see if I put the time zone there, and I put T, I guess, here to make it valid RFC 3339, then it works. But unfortunately, the word doesn't work this way, and there are many applications that don't use standard formats, so it makes sense that they want to override it with something like this, which should work. So how do they do it? So the simpler way is to make your own deserializer. So you do something like my format deserializer, and let's see if I can remember how to write a deserializer by hand. So you have this, and then you have the result of date time, and this should be error, exactly. So I'll write a very bad deserializer, but that does the job. So first you deserialize a string. So you do something like this. And then what you do is you build the date. Now, what I'm doing now won't work, and we'll go into that. Parse from stir. And so the first argument is the string, and the second argument is the format. And then usually here you would do something like this. And then you have your own string. And then you use the deserializer this way. And yeah, this has to do to UTC, and it fails. Let's see, why does it fails? I never remembered this bad thing of a format. Let's open the browser and let's go on Chrono. Here we go. So there's a strf time module. Exactly. So you have to look at this table basically and see which letter you have to use for each thing. So, oh yeah, maybe I just have to remove the Z at the end. No, it wasn't that. Okay. So what am I doing wrong? So percentage is the hour. And then you have the minute, which should be uppercase M. I have to remove the T, right? But input is not enough. Okay, so datetime, when you try to parse it, it expects one of the time zone offset to be present, and here it's not. So what you have to do is use naive datetime. And then we have to convert it to UTC. And now it works. So if you already have this method, then what am I doing with this live stream? So actually, this kind of sucks. I mean, if you have many time formats, you have to declare all of them by writing the serializer and deserializer by hand, which is annoying. Like, I feel like every each one of my projects has a third module with all of my deserializer, and there's third with, which is a crate that declares some deserializers, but I tend not to use it, and also it doesn't have this. Now, what third does is it uses a proc macro, so it would be easy for them to have a simpler way than this to declare a deserializer for a custom date format. But I don't, so it's a good opportunity to make our own crate, and this will be what I think will be the first half of this stream, and then there will be a second half where I'll actually do the what I believe is even nicer, which is a way to use the const evaluation only stuff present in the in stable to actually evaluate this format string and make sure it's valid, because both Chrono and Jeff basically evaluate the string at runtime. So your binary will contain the parser for the format string, and if there are errors, that's when there will be caught, which is too late for me, I think. And so what I like to have is something more what time has, where you can parse the format string both at runtime and compile time, depending on whichever you want, basically. And I believe there's a way to do that using just const evaluation, so you don't have to be like time, where they use a proc macro to do it, basically. So that will be the second part of the stream. Okay. So what makes the first part hard, and what makes it an opportunity to do it even better? So the easier way of doing this would be if Rust supported in Const Generic anything other than numbers, then you could in some way have the string be over here like this, or this, or I don't know how it would be, and then you would do something like this. But this doesn't exist. And I also believe this is good because you would never want to declare the string, the format string here. You would want it to be a const variable that you share with the entire project. So basically you avoid what I see happen a lot in PHP projects, where every time you want to format a date time, you redeclare the format string, and that's a very easy way of inventing new time formats. So if we make it a const, I think it will avoid the problem on the Rust side. So the solution, I haven't tried it, but I feel like it would be a very easy solution. And basically what it is have a trait, which is something like a format string or date format. And here you could either have a const or a function, depending if you want it to be DIN safe or not, DIN compatible or not. So let's go with this. So this way, it should be possible if Serde doesn't have any shenanigans that we'll definitely discover soon. Okay, so if we put this here, and then we have to find a way to put the generic here, and I didn't delve deep into Serde, but I don't believe it's possible to put the generic here. So what we have to do is do something like this, where here we have the format string, and basically we do nothing with it. So we just have a phantom data, and it needs just the f. So now it should be possible to implement deserialize for this. And I guess we also need this, but it should be possible to have it like this. Well, we'll let Clippy tell us anyway. And okay. So here, if we implement deserialize and just take this and copy paste it into it, and then here we should be able to have let's see, what am I missing? This should be possible now. Let's see. Expected zero lifetime. Yeah. This doesn't go here. Not at rate. Yes, because I put the wrong thing in there. Okay, and now I have to put this thing in here. And so now I can do something like this actually. Let's put the datetime UTC actually. So this can be this, and the phantom data just is phantom data. Okay, so this builds. Let's see if we can use it. So here we should be able to use with, and maybe I have to implement the serializer, we'll see. And here we should be able to use the generic if Serde doesn't have any shenanigans that prevents us. Okay, so now I'll just put this in here for now, but it should be possible to then keep the chrononative type in here and have Serde go through either try into or into. I don't really remember what Serde has. Okay, so we need to derive debug, and this will do. Yes, I need to import debug. Okay, so this builds. So if we run the test, it passes. So I can even show you if I debug print this. It should print the right thing. I have to put in this. And you see it correctly parsed the datetime. So obviously, if this were to be a crate that I would need to publish right now, I would refine it, and maybe we'll do later, depending on how long it takes. But what I like to do now is instead do so actually this can go away, and it still works. So now I like to do the second part actually, where we try to parse the format string using const evaluation. So actually this string. And this is something I tried a long time ago, basically when I guess time 0.3 came out. I didn't realize that they had both a macro for parsing the format string at compile time and a method for parsing it at runtime. So I was like, oh, here's an opportunity to make a crate. And then I looked better at the docs and I realized, no, they have a macro for parsing the format string. The thing is, it's a proc macro. And they try to make it as light as possible by not using sin, if I remember correctly. So they do everything by hand, but it's still a proc macro, and with some trade-offs, I think we don't need the proc macro to do this. So this is what I'd like to do right now. So let's maybe put all of this stuff in a separate file. So we'll have it later. And we'll just import the module, why not? So our tests still pass. And now let's do a part 2 where we do the const evaluation. So if I still have the tab open from before, which I don't, so let's just reopen it. So if we go to the chronodocs and we search for this, so our parser basically has to deal with all of the entries of this table, plus all of the format shenanigans that goes on with some things. I don't think I implement everything, but just the bare minimum to show that it works. And then there are modifiers, which I think apply to each one of those. I won't really go into really doing a complete implementation in this stream, I think, for this format, because it's just, I don't find anything interesting about it. I mean, it's a old weird format that even has some issues. It's just to show that there are many things that you can do with const evaluation right now in stable. So for other purposes, I think I'll just get whatever we need for this format string to be seen as valid, and nothing else, basically. So right now, if let's say we want to do something that parses this format string. Well, let's think how we would do it in a non-const function. So we'd probably have something like this, where we take an input string and we return something like parsed string, parsed format. And what would this parsed format be? Well, it would be a struct with a list of items, and each item would be something like probably an enum with let's say year, month, day, hour, and then something like this, because the format string can contain other characters which the deserializer expects, and the serializer just copy and pastes there as we put them there, basically. And so let's complete the formatter. So what we can do is something like, let's see, how do we want to do this? We can do something like going character by character. And obviously I'm not dealing with error handling right now. I mean, we already have a lot of stuff on our plate. So we'd simply have something like, let's see, maybe we can even make it easier by actually doing this. Okay, and then we would have something like this. And in the end, it would be parsed format items. Okay. And here then we would do something like see if the char is if it's the percent sign, so if it's the start of a new symbol, let's call it, or an item, keeping the terminology from here. So if this is a symbol, then we have to look at the next char. So it would be something like this, and then we, for now, assume there's an next char, and then we would match the char, so it would be something like basically this. So we can just copy this and do something like format item. And then it's simply this. And if it's something else, then we don't handle it for now. And this would simply be this. What did I do wrong? Yeah, this. Okay, and then if it's not a C, then I guess we could even make it simpler and have it like this. It's not really optimized, but it makes it simpler, so why not? So this would be like this. And now if we want to try it, we'll take the format string from here. What am I building? I'm using I'm trying to basically show how powerful const evaluation is in stable Rust right now. I mean, what I'm doing, I tried doing it some time ago, and it worked even before we had mutable references in Const Generics by writing some very bad code, but it worked. So this basically is to show how we can use them to evaluate a format string at compile time, instead of doing like how all of the libraries are doing it, either at runtime or if they do it at compile time, which for what all I know, just only time supports it, the time crate, which they do it with a proc macro, not with just cost evaluation and a lightweight macro around it. So let's try. So I'll have to put debugged statements over here, otherwise it won't work. So theoretically, this should already work for our very limited use case. And to see it, we can parse the format string. And if we run the test, what did I break? Unsatisfied trait. What did I do wrong? Parse format termination is not satisfied. What? Because yeah, I was just calling myself. So see, it works, and if I do no capture, you see that it parsed this very specific and limited format string. And you see there's here the dash, month, dash, space, and etc. So then based on this parsed format, you would actually either serialize or deserialize the date, depending on what you are doing. So this is what Chrono, GIF, and Time are doing for their runtime equivalents of their API. Obviously, it's much more complicated than this because we have to handle all of the other specifiers and also modifiers, this stuff and this stuff, etc. But this is the basic starting point for doing a minimal version that instead of being runtime, it works at compile time. So how do we do it at compile time, you would say? Because if we put const in front of this as it is, you'll see that there are a lot of things that break. So heap allocations are not stable in const evaluation. I've seen some PRs that try to add them to Vex, which is very cool, but they haven't been merged yet. And even if they were, they would only be nightly APIs, so we can't use them. Another thing we don't have in const evaluation, I believe it's in nightly behind the nightly feature, but we don't have it in stable, is traits. So there are no iterators, which is very annoying, because if you ever seen a const function, most likely you would have seen the manual way of going through a list or a range of numbers done manually without iterators, as if you were in a language that didn't have them, basically. But despite these limitations, it's still possible to implement this. Obviously, the code is worse. It's not very rusty, but it can be done. So let's put this back. So the code goes back to compiling, and I guess we'll do we'll split this into part 1 of 1, which is the runtime variant, and then we'll do part 2 of 2, which is the const variant. And I'll borrow a few things, so I still want this. This will keep. But now we have to figure out a different way of getting this done. So first of all, actually, let me go back. This implementation, putting aside the fact that it's very naive and it doesn't implement everything we have in this table, it's very crappy because everything is crammed into this one function, and we can do better than this. So what we can do is split at least this match, since we'll need it anyway on the other side, so we may as well do it here. So we'll do like function parse. I could come up with better names, but this is fine for a demo. You can complain in the chat if you want. So we can do this very basic change, and now this can be self, which I'll do, because it makes it much better to read. So this still compiles, and if I run it, it still parses as before. But now I can take this function, copy and paste it on the other side, and make it const, because theoretically everything in here works with const. Yes, it does, because it builds. So match works in const because match basically, as far as I know, it's basically a cheat. It doesn't go through the partial equal and equal implementations, but it does something different. So it already works in const. Panicking has been stable in const for a long time. I mean, there are still crates that, funnily enough, haven't updated yet and use the old way of panicking, which is to index out of bounds in a slice. Like, I think HTTP still does it. But yeah, panicking is const for a long time, as long as you don't have a format string. Like, if you have a constant string, it's okay. Maybe panic, not to do, because to do, I think it adds to do adds a prefix to the panic message, so it doesn't work. So panic works in const unless you want to print a format string, and then it doesn't work. Okay, so this was simple. Now the harder part. So let's take this and put it right here. So as we said, we can't have this vector, and we can't have this iterator. And so this we'll keep for now, but we'll not be able to use it as is. And so this will have to be something else. For now, I'll just do vecnew, because vecnew is const. So this will make the code build at least. Won't work, but it will. It will at least build. Okay, so what do we do? So unfortunately, as far as I know, here we have to do a compromise, because the only way to go through a UTF-8 string, for what it's worth, not using any external crate, is by assuming that a string is UTF-8 and not ASCII and not UTF-8, or at least we won't be able to properly handle UTF-8 because we don't have the iterator, and the iterator is the only way of going through. Now that I think of it, there's a way, which is very bad Rust, so we'll keep it for later. So what we'll do is convert a string to bytes, and then what we can do is basically iterate through each byte by hand. So what we can do is while I is less than strlen, we can do this, and this works. And if we want, we could also cast it to chars to make us believe that it's a char when it's definitely not. Okay, so now we have this part. How do we handle this part? So this part can be so here we have to basically increment the iterator. So we'll just I'll just write very bad code for now, so I'll just write it in line in here. So here we have to increment the index so that when this loops, it goes to the next char, and here it has to increment it because we have to emulate this next call. And here we put a fix me, we are assuming this. And this emulates the expect we had before. So last thing, we don't have a vec. So what do we do about it? So first thing, to show that other than the vec missing this works, I put this here, and if the demo gods, yeah, so the code compiles, and we could even copy this test, and we can at least see that it doesn't panic, which should be a further test of this potentially working. But yeah, what do we do about not having a vec? And here, I don't know if there's even a blog post from anybody about this. I believe it's a very naive thing that some other create must have done, so definitely not invented by me, like anything like this is just normal Rust. But what we can do basically is call the parse function twice. Why? Because the first time we'll know how many format items this function will return. So then we can use the result, the number, to make an array of that length, and then we can call the function a second time and actually populate the array. So let's do it. So what I said before, this vec can't be a vec. Exactly, it will be an array, and the length will be a const. Okay, so here then it's definitely it's not happy, because we would need to know the length, and obviously the user could provide the length by hand, but it's a very bad API to ask the user to basically try to make up the length of this without knowing how this works internally, and also it's not fun. So what we can do instead is add a second parameter, which is the output, and we can have the output be an option of a slice of format item. Okay, and here we can just return use size of the length of the output. So now what we can do is something like this. And here at the end, we return the length of the output. And every time we call this, we increment this by 1. Okay. So this could even be simplified actually by doing this. I don't think it would work in the actual parser, which has to deal with all of the other stuff, but for this very simple version, it will. And then what we can do is something like this. I cannot mutate, yeah. Yes. Okay, this should build, other than, yeah, the test not building, of course. So now what I can do, first I'll write this by hand, then we'll have to come up with a macro, because obviously it would be crazy to ask the user to call this function twice and with all of the boilerplate. So, but what we can do is, so let's do something like, let's put the format string into a const. And then what we do is something like this. Okay. And then once we have the length, what we can do is this. We put the length we got from here, and now we should be able to do something like this. I have to find a value. I just put here in here, just because, why not? And now what we do is we call parse again with the array. And now here we can build the parsed format with the items, which is just the array, which maybe I'll just rename at this point. And now this should be the parsed format string. Let's see, obviously I broke something. Call to non-const function. Yeah, I didn't mark it as const, obviously. That won't work. And yeah, I also have to do this because it's not copy. And this works. So if I do no capture, with the test with no capture, and we look at the part 2, which here it's everything together. So let's run just this one test. Okay, so you see this was parsed at compile time without using a proc macro. And obviously we can't expect the user to write this by hand. So the last step is to write a macro rules that does this for us. So we can do like const format. And here we just take the format string, which is let's see, I always get confused about the names of these things. It's like is this basically a literal? No, I never. I'll just. We'll figure it out. Okay, so let's see, how do we want to do this? So, so first thing, I think we can. Let's see, now comes the crazy part about yeah, I think I have an idea in mind. So we just wrap everything into into its own scope, and then we put the format string in here, and then we do this, and we'll see if it works. Or I probably have to change something, but yeah, this will be a problem. So I think the even better would be to declare the name of the variable, so that we can also put the length in here, because I don't think this will work. I think there's the idea of making it work, but it's not possible right now. So yeah, this is definitely a problem. So we'll have to take the name of the we'll have to take the name of the const. Okay. So let's see, how do we give this length to the outer thing now? So this is the part where I don't remember what I did years ago, but I guess I'll figure it out. So yeah, somehow the length has to arrive here from inside this scope. But I guess there's a very naive way of doing it, which is to just put parse in here, and this should work. So yeah, this can even be simplified at this point. So it can simply be something like, well, I don't mind leaving it as is, so it's much more readable at least. So let's see. So we'll just comment this out, and we'll instead do format parsed, and the second argument is the string. And now we'll get the compiler to complain a lot about what I did with the macro, because I'm a noob at this. So cannot find format parsed. Yeah, I think this will confuse things, so I'll just put a second D there for now. So let's see, what is it not liking? I think I probably have something. Yeah, I have something broken in the macro. Yeah, I have to put this. And now let's see what's wrong here. Yeah, I don't have this, so I'll just have to do this then. And then I also have to do this and this. Okay. So it works. No, I also program for work at my job. Yeah, I do Rust there too. Yeah, so it's very fun having to do Rust for work, but also not just Rust. I mean, fortunately and unfortunately. So I see definitely a lot of JavaScript for the front end and a lot of PHP because of legacy stuff, which the world is full of legacy stuff. So yeah, anyway, this works. So I'm not happy about having put the TT here, because it's probably too permissive, and so now I have to Google what the other options are, because I never remember them. And so yeah, let's do that. So I think there was something in the Rust book. I don't remember what it was named. It was something like Rust macro. Let's see. Maybe I can find it under macro rules, but I don't think so because it's not. Ah, yeah, it should be here. If it was somewhere around here, I think. Will I be able to find it? Let's see. Will I be able to find it? No, I don't think it was this specific section of the Rust book. It was some other section, which I never find. And I never remember the names of all of the things that go in here, so every time it's the same thing. It's not here. Will I be able to find it? Let's see. Maybe if I give some more things to Google, then it will definitely find it. I never remember. It's I think it's, now that I think of it, it's probably, this is a literal and this is an expression. Expr, maybe? No. Ah, yeah, it's true. If you get it wrong, it prints them. So yeah, it's an yeah, an is it an identifier? I suck at macros. Maybe it's an identifier. Well, it bids at least. So yeah, let's take it for granted that it's an identifier. So now if we want to actually confirm what it generated, I think, let's see, I think Rust Analyzer had something to expand the macro, but I have to call it actually on the, and if this doesn't work, oh yeah, it worked this time, but it's not helpful. But yeah, this macro is basically generating this. But actually, since this is const code, I can't show you the, I don't think I can show you the output, because if I do cargo expand, it will just be the same thing. Yeah, I don't have cargo expand on this machine. So let's install it. But yeah, I don't think it will work because a cargo expand doesn't show the output of const evaluation. I'm so used to doing proc macros in the last few weeks that I expect cargo expand to show everything, but here is probably where it won't, and it's fine. So let's expand it, and if we go to search for it, we can't even find it. Where did it go? It must be, yeah, it's inside the, I have to put this outside now that I think of it. Otherwise it will never show up in the test otherwise. Yeah, so this is not showing the output, but if we want to see it, so the test with no capture doesn't, so you know this is an array because we declared it as such here, but what we can do is break it down. So we'll just take the manual version that we wrote here, and we'll just take it back, and we can keep this one. And if we print the actual pieces you see that this length matches the length of this array, obviously. And also we can print the items, not over here because print is not const evaluatable, but we can, I guess, call this a second time and print the fact that the items are definitely in there. What did I break? Ah, yeah, that again, this thing. Okay, so this 11 is this, and this is 1, 2, 3, 4, 5, 6, 7, 10, 11. So this is an array of 11 items, like the const says. And here, when we call this, here you see it prints the array for a second time. So this is definitely working. So we could actually use this method to do various kinds of things. Like we could, for example, make a date formatter that works at compile time by simply formatting the date twice. The first time to know the length of the output string, and the second time to populate it. Or we could do things like, I don't know, write a base 64 encoder or decoder that takes the input from an include store or some other kind of input and outputs the result. And you may say at this point, why go through all of this, through this horrible code that can't allocate, can't print, can't do a lot of things? Well, there's something you can do here that can't be done with a proc macro, and that's actually to read the other const variables. So if you think of it, if let's say you have what's a good example for this? So I think I have an example in the deps.rs code base now that I think of it. So let me pull it up and I'll show you. Let's see if this is if I remembering correctly or not. Why is my computer so slow? I don't know. Am I dropping frames? Oh, I dropped just 40 frames. Okay, it's fine. Let's see, where did I have this? I think in server. Ah, yeah, in assets. So what is this? So when you go on deps.rs, and we go into network, and I'll just, whatever, clear up everything and hard refresh. So like any website, we have static assets, and the deal here was you want the browser to cache the static assets. Otherwise, every time you open a new page, you re-download the CSS and the JavaScript and fonts and whatever. But you also have the problem that if the browser caches them, then when they change, they won't change right away for the browser. So the way you fix this is by doing cache busting. So basically changing the URL of the asset when it changes. And so if you look, you see that this CSS, for example, has a cache control of a very long time, I think this is a year or a month or something like that, immutable is to say, yeah, this is definitely immutable, so don't even think of re-requesting this just because you are a browser and you know that websites are very shitty and they say things that are not true. This is definitely something you should cache for this amount of time. Okay, but how do we? And you see, this is the part I was saying, the cache busting. But how do you do the cache busting in the build of the project? So if this was a JavaScript project with a bundler, it would be very easy because the bundler would be doing the cache busting. I mean, it wouldn't be easy because you would still have to have a way for the Rust backend to know the hash of the file, so it knows what URL to put into the HTML response. But okay, let's forget about that for a moment. But in this case, we don't even have a bundler. What we have is a very simple build that runs inside the build.rs, and it's basically right here. If my internet decides to work, I mean, it's definitely streaming, so I don't know what's going wrong with the browser. So here's what's happening. We use Grass. Grass is a SAS compiler in pure Rust, and so we let it read the main SAS file, and then we get the output as a string. So we write the output, and then we write a second file with the SHA-1 of the CSS. And so now in the actual code, we have a static which contains the raw built CSS. And what we want to do is build the URL. So we want to have another const with the URL inside it, so that the web server, whenever it needs to link to the CSS, it just has a variable with the URL. And you see we are using this concat macro, which is from the standard library, which concatenates a prefix with the contents of the file containing the SHA-1. So just to demonstrate, I can take this and do it over here. So this file is definitely a mess and I should format it. But yeah, let's just do it over here. What could go wrong? Like having messy file every day we have messy files. So let's say we have something like this. So we have the I'll just copy what we had on deps.rs. So let's say we want to do something like this, and we use concat, and here we will have a different variable which contains the hash, and then we have the suffix, which is just the extension. So what I was saying before is this is a proc macro in the compiler, because concept of proc macro, because proc macros in the compiler are not implemented with sin, but I think at least with something different. So you may say, well, this is a mess because you have to repeat this prefix for every file, and you also have to put, why did you put this where you first construct the path of the file containing the SHA-1, and then you read it, and then you concat it all together in a single block. Why did you do this? Well, it's the only way you can do it, because let's say this was a separate thing. So let's say we take this and we move it here, and then we do this. This now won't work because proc macros can't read the contents of a constant, while const defense can. So if we add an implementation of concat, which actually exists, I didn't look it up, so I don't remember the name, but there's a crate that contains many things implemented as const defense. Then if we were using that crate, this would work. And so in the current state of things, const defense are much more powerful in a way than proc macros, and also they don't require seen or unseen or any other shenanigans to external dependencies to work. So this is, I think, very interesting to do. So yeah, I think this is mainly what I wanted to show in this live stream. I see it went over a bit over an hour. I hope you liked it, at least the 2 or 3 people that watched it live. But yeah, let me know if this format is interesting to you. Yeah, definitely probably have to put more work in the following live streams than just coming up with the idea in this one and doing it live. But yeah, let me know. And if you have any questions, otherwise I think this will be it. And at some point, if I feel like it, I will make this into a crate, but we'll see. We'll see when that happens. You hate this coding language already? Okay. Why? First of all, have you? If this is your first exposure to Rust, then this is definitely not the day-to-day. I believe. Obviously, it depends on what you are doing, but then there's also the, even if this was your day-to-day, it's not necessarily a bad experience. Like, for example, I maintain a crate which has a big future written by hand instead of using a sync await. And for me, it's very good because I think of that function as a state machine anyways. So it may as well be a future. But I know there are many people that say, well, this is just complicating everything and making a mess. Like, if this were using a sync await instead of manually doing the future, then it would be understandable. And I think it depends. It depends on other trade-offs you make at that point. So even this, it depends. If it's something that you are interested in, you can do it. Otherwise, you can do many other things, and you can just do, yeah. Anyway, let's see if there are any other comments. I haven't looked at the group in case somebody commented on the group. Yeah, no. Okay. In case, just instead of the silence, in case you're interested what that crate with the giant future is, it's this one, watermelon. And the giant future, if you want to see it, is, wow, my internet is definitely slow. It's here when it loads. Okay. Okay, it's getting faster at least, and it's over here. So the main piece of it is, let's see, where is it? So it's split into big chunks. So I still consider it one giant future, but the core of the future is this one. And then it calls all kinds of things. So yeah, if you want to look it up. Anyway, so yeah, I don't see any other questions. So I think this will be it for this stream. And if you're seeing this later, definitely leave a comment and I'll know if there's any interest in anything like this in the future. So yeah, have a good evening and or day, when depends where you are, I guess. And yeah, see you next time. Bye.